All right, guys, so we're going to do day 2 on vectors, and I am going to redo some of what we did yesterday, so you can just watch, but please be paying attention because I think by the end of yesterday, some of you were just writing junk down and you don't remember anything we talked about. This section started by talking about components from ordered pairs, but the first let me just revisit what we did first yesterday. We talked about that a vector had to have a magnitude, which was either a length or a force or something, and then a direction. So when we had a question like draw a vector 10 newtons long that was 110 degrees off the horizon, horizontal, we would say it's always off the positive x-axis, unless it's giving us bearings, and this was newtons, not north or something, and then this was 110. Does anybody remember how we found the components when they already told us the magnitude? This one was giving us a magnitude and direction. Super important. Somebody remembers? We just did 10 cosine of 110, and then we did 10 sine of 110. And those were the components, and that means we drew those funky parentheses. Does that sound familiar? Okay, today we're going to find the components when they tell us two ordered pairs that we're connecting. The order is important though. If it says it's going from A to B, then you subtract the ordered pair B, the X value from B minus A, and same for the Y value. And once you have found the components, okay, so you subtracted the ordered pairs. Let me do an example real quick. If you had 3, -1, and 4, 7, and this was A and this was B, and you were doing vector AB, then you would do 7 minus, X's are still first. I'm thinking slope or something, I don't know. 4 minus 3 and 7 minus -1, and you would have components of 1, 8. Then magnitude, okay, this vocabulary is very important because it will say find the magnitude, and I get people who put this down for the magnitude. The magnitude is the length. So if you were doing this question and you know the components, it means we wound up with a vector that was going right 1 and up 8, okay? So to find the length of that vector, which is written like this, magnitude, sometimes they use one set of absolute values and sometimes two, but it's called magnitude, and it is just the square root. It's just Pythagorean theorem, right? Does this sound familiar? Okay. So we did these questions. I'm just going to do maybe 2 and 3. We did them yesterday, but I'm doing the wrong order again. 7 minus -15 and -19 minus 0 to give us the components. Again, it's this second one minus first because it's going from -15 to 7. Which is a positive 22. Does that make sense, guys? And it's going from 0 to -19, which would be down 19. Then to find the magnitude, we were lazy and ignored the negative because otherwise we need a bunch of parentheses, right? Was this like 845? I don't know why that stuck in my brain. That's really sad that I have long-term memory of that number. Okay. Then, on this one, x minus x, 2 to -1 is left 3, but you could do it in the right order here. -3, -1, is that what we got, guys? And then when we did the magnitude, again, we just ignored the negatives because it was extra work to type them in, and the magnitude is square root of 10. All right, then we talked briefly at the end of class yesterday about how you find direction. All right, it says standard form of a vector is when the initial point is at the origin. And that's why Delta Math always had you drag it to the origin if you did those. If a vector is in standard position with a terminal point of AB, then the component form is just AB. Okay? If this is an ordered pair, 2 to the right up 5, then that's the components, 2 to the right and up 5, because the one end is at 0, 0. The magnitude and direction of a vector given in component form can be found using the following. Does anybody remember what we're going to write here for magnitude? It's just that square root of a squared plus b squared, yep. And then to find this angle, I would like it if this made sense to you, but if we knew x and y and we're trying to find that angle, we knew opposite and adjacent, right? So we could use tangent, inverse tangent of, and it's the y over the x, but from up here, it's b and a, okay? So it's always the inverse tangent of b over a. Now, the problem with this is that the calculator gets it wrong part of the time. If it's quadrant 1 angle, in other words, you want right and positive, the calculator will do it correctly. If you have a quadrant 2 angle, the calculator thinks you are in quadrant 4. So if it gave you, for example, negative 30 degrees, negative 30 degrees, how would you move that into the right quadrant? It's the same line. So we would add 180 to it. Okay, you will need to add 180 to move it into quadrant 2 because the calculator is going to give you a negative answer. If your numbers are in quadrant 3, so you have a negative negative, it's going to think a negative divided by a negative is what? Positive, so it's going to think it's in quadrant 1. How do you move from quadrant 1 to quadrant 3? Add 180 again. Okay. If you start with a quadrant 4 angle, and I'll explain what that means in a second. If you start with a quadrant 4 coordinates, not an angle, it will give you the right answer, okay? But it's going to give you a negative angle. If you were in delta math, you would need to add 360 because it wants a number between 0 and 360. Now, let me just go through a couple examples real quick. So if the components were 2, 5, can someone do inverse tangent of 5 divided by 2 in degrees? Degree mode, inverse tangent, 5 divided by 2, 68 degrees, or, because I think they round to the nearest degree, I would have probably put 68.2, but doesn't matter. All right, that's true. 2 over 2 up 5, 68 degrees, you're good. What would be an example of an ordered pair that's in quadrant 2? Can anybody tell me? If you're in quadrant 2, the first number is negative, and the second number is positive, right? So do inverse tangent there for me. Inverse tangent 7 divided by negative 3. Thinks I am negative 67 degrees. Is that true? Is that what you got? Okay. But it said over here I want left and up. So how can I be down in quadrant 4? So the solution is just to add 180. You get 113 degrees. Does that make more sense that you went left and up? It should be at something in quadrant 2. All right, a quadrant 3. Anybody give me some numbers for a quadrant 3? There we go, negative 4, negative 1. So you would do inverse tangent of negative 1 over negative 4. And it's going to think you meant a positive, so it's going to give you a quadrant 1 number. I got 14 degrees. Anybody else get 14 degrees? Okay, going left and down does definitely not get you in quadrant 1. But if we add 180 to that, we'll get 194. Is that seem more like a quadrant 3 number? Okay. And I'll show you the last quadrant, positive, negative, if you had like 2, -3. So you did inverse tangent of -3 over 2. It's a number I would take. Is it -56? I got -56 degrees. That's a quadrant 4 angle. We were in quadrant 4. I would take that number. In delta math, actually, I think if you put in that number in delta math, it gives you a little message that says the angle should be between 0 and 360. It doesn't just count it wrong, but you would have to add 360 to that, okay? So we'll say, or, we did plus 360, is it 304? Does that seem okay? All right. So I don't want you to write down all those rules and try to memorize them. I just want you to pay attention to the components. Will tell you what quadrant you're in, and you need to make sure your angle lands in that quadrant, okay? All right, so let's go back real quick and just talk about number 2 and 3 again. This was in what quadrant? 22 to the right and down 19. 22 to the right and down 19 is 4, right? It's down here. This is quadrant 4. So we would type inverse tangent of -19 over 22, because it's always the y over the x. Tangent always is y over x. I got -40.8, or we could just go with -41. That would be fine, okay? Or you could add 360 to it and use 319. Everybody okay? On this guy, where was -3, -1? Left and down is quadrant 3. If we do inverse tangent of y over x, a negative over a negative, inverse tangent, anybody get 18 degrees? Okay. Is 18 degrees in quadrant 3? Let me show you why it's 180, just in case we're confused about that part. If I go over 3 and up 1, it makes an 18-degree angle. And you instead went left 3 and down 1. Do you see that that would make a straight line and it would be 180 that you're moving beyond? So we get 198. I feel like that's a number we just did. But anyway, we good? All right, so we're going to move on to the next page. This is a quick review. These two shouldn't freak you out too much. What is this giving us? What does this notation mean? Magnitude and an angle. So I could make you draw this. I'm not going to, but let's see, 240 degrees would be down here somewhere, right? And it's 18 units long. But you don't have to draw it at all. All you got to do to find the components is, remember from yesterday? 18 cosine of 240 and 18 sine of 240. Is 240 a number on our unit circle? It is, isn't it? So you could type this and get decimals. They will sometimes offer exact answers in different places. What is the cosine of 240? 246, is it -1/2? And the sine is negative square root of 3 over 2. Okay, so if you wanted an exact value, you'd get -9, and this 18 and 2 would reduce, you'd have -9 square roots of 3. But I'm really okay with decimals, which should give you -9 and some decimal. Did anybody type it? 18 sine of 240. Negative 15.6, but the 9 came up exact, right? Okay, so I'm fine with this answer. All right, so do this one. Can you just type this one? You should just be doing 5 cosine of 95. That's a good question. Yes, I'm pretty sure. If you even have to do this kind. Emma, did you get the X value? Did someone else get that? 95 degrees is barely into quadrant 2, right? So that's what's a little bit tiny negative number. Okay. And 5 sine of 95? Go ahead. Somebody? Anybody? 5? Oh, it's 5? Literally? Sorry. I was like, what? Sorry, guys. Thanks. All right. It must round to 5, yes? Okay. Because 5 sine of 90 would be right on 5, but it doesn't matter. Okay, we're good. Component form will help us add vectors, okay? So adding vectors, you can just add the components. That's literally all you have to do. So if you had component form of 2, 3 and negative 1, 7, you had 2 vectors, you could just add the components and get 1, 10. Add the x's, add the y's. Does that seem okay? Easy peasy. All right. They do say you can also subtract if you know the components. And a scalar multiplication, what that actually does is lengthen something. So if you knew you were going over 2 and down 1, and you multiplied by a scalar, which means just a quantity out in front, it would become 8, negative 4, because it just takes, you're going like right 2, down 1, right 2, down 1, 4 times, okay? So it's just increasing the length 4 times. So there's some really easy stuff we're gonna do with these, and then we're gonna talk about the application problems. So the first one, a first example just says add these. 4, 2 plus negative 1, 3, we would get what? 3, 5. There we go. Do we need to write down what we did? 4 plus negative 1 and 2 plus 3. Done. All right, there's an example here of 3s plus t. So you would just multiply the 4, 2 by 3, and they got 12, 6. They kept the t the same, and then they added them together. Seem easy? So let's try these. Uh-oh, we got to subtract. So f is 4, negative 2. And we're supposed to subtract g, which is 24, 21. So 4 minus 24 in the x spot would give us what? Negative 20, okay? And in the y spot, negative 2 minus 21 would be negative 23. Did I do that right? Please holler if I didn't. I think it's right. Okay. And then can you try this one on your own? G plus 3f's. So what is 3f's going to make that one? Yep. Multiply it by 3 and then just add it together. Do you wish that was the whole quiz? Did anybody get 3615? Okay. Any questions on those? Happy days, right? Okay. A vector that has a magnitude of 1 is called a unit vector. Its length is shrunk down to 1, okay? A unit vector in the direction of the positive x-axis is called I think they use this a lot in electrical engineering. And a unit vector in the positive y direction is called J. Vectors can be written as linear combinations of unit vectors by first writing the vector as an ordered pair and then writing it as a sum of I and j. We aren't going to do much with this, okay? The unit part, you just divide by the length. So let me do a real quick one. If I had 3, -4 as my vector, the unit vector, so it's right now going 3 to the right and down 4, okay? What is its magnitude then, guys? Can you do Pythagorean theorem for me real fast? 5, right? But if we wanted to shrink this down so its length was 1, what would I have to divide by? That makes sense? I have to divide everything by 5. So to make this a unit vector, you would make it 3/5 and -4/5. I'm not going to ask you to do unit vectors, okay? But the linear combination ones are really easy, so I assigned a couple. Linear combination just says you take a vector and you put in an I on the X term and a J on the Y term. That's it. So their example here was, say you went from M to P, we would do the same way we did yesterday. 5 - 2 and 4 - 2 would be 3, 2. And then you just, instead of writing 3, 2, you write 3I plus 2J. It's a different notation, okay? It's used in certain fields. They call them IJ instead of just components, okay? So we're going to do that here. So -5 - 2, remember you subtract, if you're going from M to N, you went down 7, right? And -3 - 8 would be down 11, or was left and down, I guess, but did I do it right, guys? -5 - 2 and -3 - 8, I think those are right. So what would that look like as an IJ vector? -7I minus 11J, that's it. I think you could do that in Delta Math. Easy peasy. So do this one. Make sure you do it in the right order. Anybody have an answer? Oh, that's not an I, Hofbauer. Okay. 18 minus 0 was 8. Oh, yeah, that's a 0. 18 minus 0 was 18, and 4 minus 6 was -2. Okay. Find the direction and magnitude. Oh, direction, it says. Just find direction. We're going to practice finding direction. This one is given in a form that I probably won't give you one on the quiz. I don't think I put IJ on the quiz at all, honestly. I think it's assigned in Delta Math because it's easy. All right. How do we find direction again? Direction is an angle. How do we find an angle? Inverse tangent. Yep, 2 over -4. In degree mode, I got -26.6 or -27 degrees, maybe. I think I did everything to the 10th on the quiz. The directions say 10th. By the way, this quiz, you have to switch from radians to degrees. I put it in right in the directions, okay? So just make sure you read directions. Is that the right answer? What do we always have to check? -4, 2 is over here, right? -4, 2. So is -26 telling us the right angle? -26 would be down here. How do I get over into quadrant 2? Add 180. So the right answer should be 153.4. Okay. Think about what quadrant am I in on number 11? 217. quadrant 1, right? Positive, positive, and it's not going to mess that up. So we just have to do inverse tangent of 17 over 2. Oh, where am I typing? Inverse tangent 17 over 2 at 83.3. Anybody else? Okay, we're golden. It's in the right quadrant. Done. All right, so adding vectors means finding the resulting force and direction after you've found the components and added them together. So if 2 or more forces are acting on an object, then the resultant force is the sum of the 2 vector forces. Application problems almost always ask you to add vectors. There's going to be 3 steps to this. You're going to need to make sure you have the components. So you want an answer like this. And then you're going to need to find the magnitude, which means you want to do the square root of, right? A squared plus B squared. And then you are going to want to find the degree or direction. So you're going to do inverse tangent of y over a b over a. Sorry, that's a b. Okay. When you have the components, you're going to add them together just like this and get new components. Okay, so that's the steps. Let's try it. Monica's throwing the javelin in a track meet. While running at 4 meters per second, she throws the javelin with a velocity of 28 meters per second at an angle of 48 degrees. Okay, it's a little confusing, and I would not put this on a quiz, but she was running 4 meters per second straight this way. What would the angle be on that? Just be 0 degrees, yes? Okay, so we're going to call that vector her running. 4 cosine of 0, 4 sine of 0. Or you could just call it 4, 0 because it's moving her 4 to the right. But that's what it's going to come up when we type that in, so I'm going to leave it that way. And then she throws the javelin with a velocity of 28 meters per second at an angle of 48 degrees. So it's still off the horizontal, positive 48, so we don't have to do anything funky. We just write the javelin, or the throw, whatever you want to call it, is 28 cosine of 48 and 28 sine of 48. Now you could type those in and write decimals down. I suggest you practice just adding them from this format, okay? Let me show you what I mean by that. So to add them straight down, I'm typing 4 cosine of 0, I'm in degrees, okay? 4 cosine of 0, close the parentheses, and then I'm going to do plus, somebody tell me, was it 28 cosine of 48? Thank you. Okay, so my added components result in a 22.74. I'm going to carry an extra place on this. You don't have to if you don't want to. I will accept a lot of leeway, but I'm going to write 27. Was it 7.4? Is that what I just said? Oh, 22.74. Okay, I'll fix it. And then we got to go back and do 4 sine. We're adding the y's now. 4 sine of 0, which should just be 0, plus 20, oops, close your parenthesis, 28 sine of 48. Now, I got to tell you, on the quiz, students get the numbers backwards. They'll do 48 and 28. How do you know which one goes where? The one in the parenthesis is always in degrees. Yeah, 20.81. And this one was supposed to be 22.74, right? Okay. Are we done? Is that the resultant speed? Those are the components. The resultant speed means magnitude. And how do we do magnitude? Yes, the square root of 22.74 squared plus 20.81 squared. You could type it and then square root it, whatever. I got 30.8, and I'm going to round to a tenth now. Anybody know the label on that? Meters per second. Good job, because that was the resulting speed, and we were using the same labels for the two vectors here. All right, resulting direction, we got to do what? Direction requires us to do inverse tangent. Which numbers are we using? Yeah, these guys, y over x. Uh, 20.8 was it on top? And then okay. And I got 42.5 degrees if I round to the nearest tenth. Especially as long as you show your work, I won't be picky on rounding, okay? But make sure there's work so that I can tell what you were doing in case you get a different answer than I do. All right, so seem okay? That one's a little complicated because I didn't give you all the information really. This one is also a little complicated. The ones I put on the quiz, I was very literal with. It says Walter is kayaking across a river that has a current of 2.5 meters per second. Okay, it shows it's doing this. If it's going straight that way, what is our angle? 0. So we're going to do for the current, we're going to write 2.5 cosine of 0 and 2.5 sine of 0. Okay, that's the current. And I'll switch to blue for his paddling. He is paddling at a rate of 4 meters per second perpendicular to the shore. So he's trying to paddle straight across. So that angle would be just 90. So we're going to do 4 cosine of 90, 4 sine of 90. Now, is he going to wind up straight across if the current is pushing him downriver? No. So we want to find out what's actually happening to him. So we're going to add these, and that's going to give us the resultant components, but then we have to find the resulting velocity and angle. So first we just add, and we get 2 components. Let's see, this time I'm just going to do it on this. 2.5 cosine of 0. If you're typing it, you need to close your parenthesis. 4 cosine of 90. I got 2.5, yes? Because the only force going to the right is the 2.5. And then 2.5 sine of 0 plus 4 sine of 90 should be 4 because the only force going, does that make sense to anybody? Because they were directly opposing. Okay. But this is the same pattern we're going to use for all of them. So I want us to actually think about typing it in. Okay. How do we find magnitude or resulting velocity? Square root of 2.5 squared plus 4 squared. 22.2. Oh, I didn't square root. Sorry. 4.7, anybody? 4.7 meters per second. Does it make sense that he's moving a little faster than he thought because the current is pushing him along? but he's definitely not going to go straight across. So let's figure out what the angle would be. Inverse tangent of y over x. I got 58. Why is it not exactly 45? Because there's one force going across, one force going to the right. Yes, because he's going, it's pushing, he's pushing with more force than the current, right? So he's going a little further across than he is to the right. Okay. All right, these are wind problems. I do hereby solemnly swear I did not put an exact wind problem on the quiz, though this one is not real difficult. 300 kilometers per hour due east. What would that mean? Here's your vector, so what are we going to type? Angle? Anybody? Angle for due east? Cosine of 0, sine of 0. Okay, so that was the plane. That's what it thinks it's flying. But there is a wind pushing on the plane. And this is where students get confused, and so I did not put one of these on. A wind is blowing 35 kilometers per hour, 75 degrees south of west. Now, this one is a little confusing. I'm going to go with it's blowing towards this direction. It's pushing the plane this direction. Sometimes we've had problems where they said from this direction, so it's pushing it at opposite direction. Gets really confusing. We're not going to mess with those this year. So 35 kilometers per hour, 75 degrees south of west. So off of south towards the west, 75 degrees would be in here. And it's blowing 35 kilometers per hour. So it's going to be 35 cosine of something and 35 sine of something. But here's where it gets confusing. Any ideas? We need the angle off the positive x-axis. Couple ways we could find it. What was this south line? 270, right? Yes, 90, 90, 92. We could just do 270 minus 75. Or we could do 90 minus 75 is what, 15? Did I do that right? So 180 plus 15. Is it 195? Did somebody do either one of those? 180 plus 15 or 270 minus 75? Okay, 195. Now do you know why I'm not putting this on the quiz? Okay, but once we had the components, literally on the quiz, I give you the length and the angle to use, okay? So it's not confusing. But now we're going to add them straight down. So 300 cosine of 0 should just be 300 plus 35 cosine of 195. If you're not getting these, please be typing because we need to know. Ooh, I got 266.19, or I can round to 0.2 now. I don't really care. Did someone else get that number? 266.19? Okay. And then 300 sine of 0, close parenthesis, plus 35 sine of 195. I got negative 9.06. All right. Does it answer the resulting speed of the plane? This question only asked for the speed, but do we have the speed yet? What does the speed require that we do? Yep. And why am I ignoring the negative? Because once I squared it, it would become positive anyway, so I don't want to have to do a bunch of parentheses. Oops, not degrees, just kidding. Kilometers per hour, right? 266.3. You got 0.4? Did you guys round? Yeah. Okay, it doesn't, 0.3 or 0.4, I would not, yep, I'd be fine. Believe me. If you rounded to 266.2 and then 9.1, then you get 266.4. It's fine. I was very careful to make sure that there's room on the quiz. You know, I wrote both answers down and accept either one. Okay. Think about this for a second. If the wind, the plane thinks it's flying 300, but the wind, and it's flying east, wasn't it? So the plane was going this way, 300, and there was a wind pushing it this way at 1/10 of that, not a lot, but would it slow down the plane? Okay. And we could do inverse tangent and find out how far it's pushing it off course, but that gets really complicated. Not because it's tricky, but because they measure that off of different directional angles. Okay? We'll maybe do this one as a warm-up tomorrow. This is more like what's on the quiz because I literally tell you what angles to use, okay? So your homework, oh, there's not a slide that says your homework, is simply delta math. That's it. Let me see if I pull up the Google Classroom. Does it have it? Just kidding. That's not the quiz and it's not in the recording. Our lesson plans. Don't want that. Go away. Oh, lesson plan. Right here, Delta Math Vectors Part 2. Okay? If you have trouble because I didn't get to doing any Delta Math examples, let me know tomorrow and we can go over some. Otherwise, tomorrow we're starting probability.